Stretching the graph of f of x vertically away from the x-axis is given by a times f of x, provided that a is greater than 1. F of x stretches away from the x-axis by a factor of a. Consider f of x equals x squared, here in red, and one of its transformations, g of x equals 2 times f of x. That's here in the blue graph. The graph g of x is the result when f of x stretches away from the x-axis by a factor of 2. So it stretches away this way, see, from the x-axis. Shrinking the graph of f of x vertically towards the x-axis is given by a times f of x, provided that a is between 0 and 1. F of x shrinks towards the x-axis by a factor of a. Consider f of x equals x squared, here in red, and one of its transformations, 0.5 times f of x. The graph h of x is the result when f of x shrinks towards the x-axis by a factor of 0.5. So you have our original graph in red, and then it shrinks towards the x-axis. Use the function f of x equals x squared minus 1 for each problem below. Write the rule or formula for the new function after the transformation. Alright, so we're using x squared minus 1, so we have 3 times f of x equals 3 times x squared minus 1, which is 3x squared minus 3. Here we have 5 times f of x, which is 5 times x squared minus 1, which is 5x squared minus 5. And finally, we have 1/2 f times f of x, which is 1/2 times x squared minus 1, which is 1/2 x squared minus 1/2. Let f of x equal 4x minus x squared. Its graph is displayed to the right. The function g is given by g of x equals 2 times f of x. So we take f of x and we multiply it by 2. And that gives us 8x minus 2x squared. So now let's do a little graph. Let's plug in some numbers and see what we get. So when x is 0, we still have 0 as our intercept. However, when x is 2, we have 8 times 2 minus 2 times 2 squared. So 16 minus 4 times 2 is 8 equals 8. So our coordinate is 2, 8. So it's all the way up here. And finally, when x equals 4, so we have 32 minus 16, 32. That equals 0 again. So now our graph looks like this. So we can see that our graph now goes all the way up there, but still has the same x-intercepts. So what's a formula for g that does not involve f? Right here. We have 8x minus 2x squared. Stretching or shrinking the graph of f of x vertically away from or towards the x-axis is given by a times f of x. If a is greater than 1, f of x stretches away from the x-axis by a factor of a. If a is between 0 and 1, f of x shrinks towards the x-axis by a factor of a. Consider f of x, the red graph here. Let g of x equal 2 times f of x. So it follows that if f of 1 equals 2, then g of 1 would equal 4. So it goes up here instead of being down here. The point 1, 2 here stretches away from the axis to the point 1, 4. So the y-coordinate has doubled. Let's consider f of x again, and let h of x equal 0.5 f of x. So it follows that if f of 3 equals 4 here, then h of 3 will equal 2. So we cut that y component in half. So the point 3, 4 shrinks towards the x-axis to the point 3, 2. So the y-coordinate was divided by 2.